Today, we're diving into the absolutely incredible story of Earth's first breath, a saga that unfolded over billions of years and literally created the world we know. But before we jump in, just do me a favor. Take a nice deep breath. Feel that? That oxygen you just pulled into your lungs is a pretty new thing for our planet. For most of Earth's history, the air, well, it would have killed you instantly.
So to really get a grip on how we got the air we have today, we've got to go way, way back. Back to when Earth was, honestly, a truly alien world.
Okay, so check this out. This chart is basically a snapshot of what Earth's atmosphere looked like 4 billion years ago. The air was this thick, toxic soup of hydrogen, methane, and other gases, with almost zero oxygen. I mean, it wasn't just different, it was a world we wouldn't even recognize.
Yeah, the difference is just, wow, it's night and day. Early Earth's atmosphere was a lot more like Jupiter's is today, chock full of hydrogen and methane. What we have now, this breathable, oxygen-rich air, it didn't just happen. It's the result of a total planetary makeover.
All right, let's look at that chart again. See those lines, the red one and the yellow one? That's your hydrogen and methane. They were the kings of the sky at first, but then, boom, they just plummeted. This was the first huge shift in our planet's atmosphere.
So while those gases were on their way out, something else was moving in. Take a look at that blue line. That's nitrogen. It just starts climbing, and it eventually became the main gas in our atmosphere, giving us this stable backdrop that life really needed to get going.
Okay, but hold on. What about oxygen? The stuff we actually need to, live, it's nowhere to be seen in this picture. So where on Earth did it come from?
Well, the answer, and this is the really cool part, didn't come from rocks or volcanoes. It came from life itself. Life was about to completely re-engineer the planet.
You've got to picture these tiny, tiny microbes just hanging out in the ancient oceans. And about 3 billion years ago, they came up with an idea. And it was an idea that would change the entire world.
We call this process oxygenic photosynthesis. It's a bit of a mouthful, but the idea is simple. These little guys figured out how to use sunlight to turn water and carbon dioxide into energy. And the waste product? The stuff they just burped out? That was oxygen.
But here's the crazy part. For almost everything else alive at the time, oxygen wasn't a gift. It was a deadly, corrosive poison. It was literally the planet's first great pollution crisis.
Now, this pollution, this oxygen, it didn't just flood the world all at once. Nope, it took hundreds of millions of years for the planet to hit a tipping point, a moment we now call the Great Oxygen Event.
All right, check out this graph. It shows the amount of oxygen in the air over Earth's entire history. And look at that flat line at the bottom. For more than 1 billion years, these microbes were pumping out oxygen, but it was all getting sucked up by iron in the oceans and rocks. It just couldn't build up in the atmosphere.
But then, around 2.4 billion years ago, everything that could absorb oxygen was full. The system hit its breaking point, and all that oxygen that had been locked away, it just burst out, flooding the atmosphere. This, right here, was the Great Oxygen Event, probably the single biggest environmental shift in our planet's history. And when I say flooding, I am not kidding. The increase was absolutely staggering. We're talking a 10,000 times increase in atmospheric oxygen. It happened in what's basically the blink of an eye, geologically speaking. The world was never, ever the same.
So you have to understand, this event was two things at once, a total catastrophe and an incredible creation. On one hand, it wiped out most of the life on the planet that couldn't handle oxygen. But on the other hand, it opened the door for a whole new kind of life. Life that could breathe.
So, with this brand new oxygen-powered atmosphere, life was ready for its next great adventure, crawling out of the sea and onto the land.
If we go back to our oxygen graph, you can see this second big jump right around 1 billion years ago. This is what really stabilized things, creating that oxygen-rich world that bigger, more complex things like animals and plants needed to really take off.
And this is where things get really familiar. This is basically the family tree of plants, and it shows just how life exploded in this new world. It all kicked off with algae in the oceans about 1.5 billion years ago. And man, from that first algae to the trees in your backyard, what a journey. About 420 million years ago, plants finally made it onto land. Then they invented seeds, then strong woody structures, and finally, flowers. Every step was a new way to thrive in this oxygenated world.
And all of that, all those billions of years of evolution,
brings us right here to today, to the very air you and I are breathing right now.
So here it is, the final product of that 4 billion year-long project. We've got an atmosphere that's about 78% nitrogen, which is that stable backdrop, and a critical 21% oxygen, the perfect cocktail for complex life like us.
So if there's one thing you take away from all this, let it be this. The air all around you isn't just there. It's not just some random mix of gases. It's a biological construction. It was built. The air you just took a breath of was made over billions of years, by life, for life.
You see, Earth's atmosphere has never been a static, dead thing. It's a living, breathing system that's constantly being shaped by life. And today, we're the dominant force shaping it, which really leaves us with a big question, doesn't it? After 3 billion years of the story, what is our chapter going to look like?